All right, let me get that. Oh. There, that's good. We're going to do something called solving by substitution, if I can get the camera set up here properly. There we go. Okay, solving by substitution. Now, on this slide, I have a video that I'm going to show you solving by substitution. I've also put in a video from Khan Academy to have a different look at it. And then there's another slide a little later on to explain it as well. It's really an algebraic method of getting the answer. So we have two equations here. If we were to graph those two equations, right, we would end up with, I don't know, a line like this and a line like that maybe. I'm not exactly sure. But if you graph it, you're going to end up with two lines that will cross. Okay? So this is another way to do it that does not involve graphing. It's called solving by substitution. It's all algebra. The first step, step one. Okay? Step one, and I'm going to get a different color here. Step one is to isolate a variable. Now, I have an x variable and a y variable in the first equation. We'll call that equation 1. I have an x variable and a y variable in the second equation. We'll call that equation 2. I can pick any of the four variables, any of the x's or any of the y's, and isolate it, which means make it x equals or y equals. In this case, I'm going to choose equation 2. I'm going to choose y in equation 2. And why I'm going to do that is because I notice there's no coefficient in front of the y, makes it a little easier to isolate. So if I have 3x plus y equals 19, I can just move the 3x over to the other side. It becomes negative 3x. So y, this 3x becomes negative 3x, and that's a plus 19. Now you'll notice when we move it over, we put the x first, right? And the 19 is a positive, so it stays a positive with this sign switch. Now we've got it in y equals mx plus b form. We could graph that, right? We could graph that. We're going to get rid of this, because this isn't accurate at all, okay? But we could graph this. We're not going to. What we're going to do now is we are going to, and this is why it's called substitution, step 2 is to substitute into equation 1, okay? Substitute into equation 1. That's our second step. This is why it's called substitution. So this is step 2, okay? All right, so how do we do that? All right, well, we literally say, this is why I'm going to put this value of y, okay, into equation 1. Okay? So I'm going to take equation 1, I'm going to rewrite it, 2x minus 5y equals 7. Remember, it's a process. I'm going to say, well, if I know that y equals 3x minus negative 3x plus 19, why couldn't I put it in there? Minus 5. I'm going to substitute that because I know what y is. Okay. Two reasons you can do that. One is because, remember where the lines intersect, the x and the y have to be the same in each equation. So if I draw this really quickly in black, just kind of two lines, and they intersect right there, and they get a point x and y, you'll notice, because that point is on both lines, that xy value must be true in equation 1 and in equation 2. So it gets a little bit complicated how it works, but that x got to work in both, which means this x value is the same as this x value, and this y value is the same as this y value when it intersects, and we only care about when it intersects. So if I know that this y